Now, one of the first things we want to do with a point is we want to be able to say how far apart 2 points are. And in particular, we're going to look right now at how far this point, 1, 2, 3, is from the origin, which is where the axes meet. So I'm going to draw on some helper lines here. So A is showing a little line that goes out from the origin by 1 in the x direction. And B is going to go in the y direction by 2 from where that A segment stops. And then I'm going to put on this segment D, which is going to go straight up in the z direction. So if I move this around, I think you can see that A and B are going in the x and y dimensions, and D is going up. And we're going to figure out this three-dimensional distance here from the origin out to the point 1, 2, 3. And we're going to do it by making some right triangles and using the Pythagorean theorem. So the first segment I'm going to draw in here is C. So I'm going to turn this, so we're just looking at the XY plane straight on, and I have A and B and C. Oops. And I'm going to move those over. I'm going to take a picture so that I can label some things. And now what I'm going to do here is I'm going to do some labels. So if I was going to use the Pythagorean theorem, I would say a squared, that's that length, plus b squared, that length, equals c squared. So there's my Pythagorean theorem there. I'm going to save this and paste it into this document so we can compare it to our next right triangle in a minute. So the next right triangle, I'm going to take and I'm going to say, all right, what I want to do now is I want to go straight out from the origin to this point and then up by D. And if I turn my plane so I'm looking at that straight on, you can see that's going to go straight up at a right angle. And when I put in another segment, this is the one that goes from the origin out to that point, you see. This CDE also makes a right triangle, and so I can use the Pythagorean theorem again. And so here I'm going to say that this length going out here, that length is C. That's D. And so the Pythagorean theorem says that c squared plus d squared equals e squared. E is the hypotenuse. And if I put those two equations together, so I saved the last picture here so I could have these two pictures side by side. And so I'm going to take and put those two equations together there. And if I write the equations down again, a squared plus b squared equals c squared, and I substitute that c squared into this equation, c squared plus d squared equals e squared, then I get a squared plus b squared plus d squared equals e squared. That is my big useful form. And so going back to my 3D picture here, where are you? There you are. The A is the distance out in the x direction. It's 1. The B is the length in the y direction, that's 2. And the D is the height, it's this z direction length, 3. So for my point 1, 2, 3, A is 1, and B is 2, and D is 3. And so what is that? Well, this is the x direction distance, and this is the y direction distance, and this is the z direction distance. And that gives us a distance formula that should look pretty familiar. So you should know the 2D distance formula. Which looks like this. Subtract off the 2x coordinates to find out the x distance between them. Subtract the 2y coordinates to find the distance between them. Usually we write these in the same order, though it isn't going to make any difference because of these squares. And you square them and you add them together and you take the square root, and that is the distance. And so the 3D distance formula, if you know the 2D distance formula, it should be easy to remember the 3D distance formula, because you just take that 2D formula and you add a z in for the third dimension. So I take the x coordinate difference and square it, the y coordinate difference and square it, and the z coordinate distance and square it. And the square root of all of that added together is the distance. So that's going to be our new distance formula. Distance formula that's one of our important formulas for today.